we're beginning here in 1.3, talking about measurement. If you want to go there with me, it starts on page 14 in your textbook. What do we mean? We've talked about SI units. We've talked about how we use them. When I say we're going to take a measurement, what does that mean? Someone got a raised hand? What does that mean? I'm going to take a measurement. I know those are words you've used before. What does it mean? Yes, ma'am. Okay, so we're actually trying to find something out about it, which I agree with completely. Something you want to add? And that's one of the key words I wanted to make sure you all heard, was that we're comparing it to a standard, right? That's what we spent all this time talking about, SI units, right? That is the standard. And you are comparing whatever you have to that unit via a standard, okay? For length, how do we do that? Give me some ideas. We're talking about length. How do I compare? Like, what standards am I comparing it to? A meter, okay, but how would that look in your life? Like, what might it be? A ruler, okay, or a meter stick or a yardstick or something like that, right? You could take steps, right? I'm always impressed at the referees in football that measure these things, by just their actual steps. Oh, that's a yard. There are caddies on the PGA Tour. They can't use anything to tell how far away they are, so they have to literally pace off. That's their standard. Their stride is exactly 1 yard in length. They've worked on this to get this standard. Are we cool? So again, measurement is all about a standard. So we're comparing to a standard. And that's the key piece. To a standard. Okay, so when we're comparing results, because if we all measured, we're going to get different numbers, right? We're hoping that they're pretty reliable, but there may be some differences in there. So how can we tell whether the measurements are good or not? One of the first ways, or one of the easy ways you'll see us do this, is by using what's called a standard deviation, or an average deviation. The lab we're going to do tomorrow, actually, you have to calculate what is the average deviation. And it's pretty easy. Here's what we do. If you have a set of measurements, right? So they've given you a data set, 7, 9, 5, 7, 2, 6, 4. First, you have to sort it numerically. So from lowest to biggest, right? 2, 4, 5, 6, and you'll have this exact thing on your lab tomorrow. Don't feel like you have to write this down. Okay, but it is there on your lab. You sort it numerically, then you find the median. What does median mean? The middle, the very middle number. It doesn't mean you average. That's a different term. Median is just the absolute middle number of your set. In this case, that number is 6, right? We're cool? If you have more than one data set, you take the two middles and you average it. Then we find the absolute value of the difference between the median and each number. So, my median was 6. So I take 6 minus 2, that gives me 4. 6 minus 4 gives me 2. 6 minus 5 gives me 1. 6 minus 6 is 0. 6 minus 7 is negative 1, but I want absolute value, right? Because I want all positive numbers. So that I get 1 and 1 and 2. So here's my differences when I'm comparing to the median. We're cool? And then I take those, I add them together and divide by the number of numbers or number of data points I have. I'm finding the average, right? The mean. And so that mean is 1.571423. And they've rounded here to 3 significant digits. So 1.57 is my standard deviation. Yes, ma'am. I'm okay with that. If you know how to do that, that's fine. Yep. This is, again, just a way to do it, perfectly. Yes. Sir? Why did they do 9 minus 7 at the end? Because 9 was one of the numbers in the set. These should be both -6. You're right. You're right. Yes, 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 yes. Yep. The difference from the mean. The median is 6, so you'd subtract that. You're correct. Hopefully that's the right number. Maybe it's there. I didn't make this. I got this from somewhere else. Yes, sir. Yeah. That's what Jason, we were just saying, that there's some mistakes here, that they put the wrong number there. Yep. They put the wrong number there. I'm assuming this is correct. If not, again, just find the mean from those differences, and that's your standard deviation. Okay? Are we cool? And so, take a look for me on page 15 in your textbook. Everybody has access to view a textbook? Okay, good. Page 15. Look in that top right corner, figure 10. You've got 3 students who have took some measurements. They're measuring the length of a spring. And one student, so let's call that student 1. What was the number that student got? Like what was the measurement they got? Well, the actual measurement they got was the black line. So 14.6. What does the red line represent? What does the red line represent? The uncertainty, the standard deviation, right? So they're saying that they have a plus or minus 0.2 in their measurements. Does that make sense? So the actual number could be anywhere between that range. She got this number, but this is the range. This is the standard deviation of what it could have been.
You also do that with resistance, like special terms.
Oh, sure, yeah. You can use these with any measurement you're taking. How about student 2? What was the measurement they found? 14.8. And what was their standard deviation? Plus or minus 3. 0.3, right? How about student number 3? What did they get? 14 on the nose. And what was their deviation? Okay. So, can you make any evaluations of this measurements, this data you've been given? Anything that sticks out to you? Any thoughts about this data? You would think they're getting different numbers, which that's not unusual. It's not unusual. Okay, student number 3 is most precise. We'll talk more about this. What do we mean by precise? Their range of uncertainty is very small, right? Okay? But does student 3 agree with student 1 and 2? Yeah, I mean, there's a pretty significant difference, right? Because 1 and 2 are at 14.6 and 14.8, and student 3 is all the way down there at 14.0. Does that make sense? So we want our measurements. We're measuring the same spring. They should be pretty close to the same pieces. It's a good question. There are statistical tests you can do to help determine how relevant or how significant those findings are. We're not too worried about that. Yeah. No, I hear you. Yes. The uncertainties are similar. That's what they're saying. You know, hey, these aren't. There's not a huge wide range between them. I hear you. Are you with me, friends? Because again, tomorrow in the lab, you are going to calculate. We're doing 2 or 3 little activities, and you are going to calculate that uncertainty of those pieces. Okay. All right, let's continue. Let's talk about accuracy and precision. And I love how they show you this on the bottom of page 15. This is the best way I have seen accuracy and precision to really be understood. Okay? So precision has a definition in your textbook. How would you define precision? Okay, or close together. How does your textbook define it? Okay, degree of exactness, how exact they are, right? So, if we put a bunch of, so let's use this one. So, how tall am I? Anyone have any guesses?
6'6".
I'm over 6 feet tall. We cool? Okay, now let's get a little more precise. Some of you tossed out some inches there. You said 6'3", 6'4". I'm about 6'4", 3.5 or so. So 6'4". So are you comfortable that's more precise than he's over 6 foot tall? You cool? So I'm 6'4". Let's make it even more precise. I'm 6'3.75". We cool? Could we make it even more precise? And we could, right? Depending on whether I've cut my hair, if I'm standing up straight, right? I mean, we could keep going down in decimals. That's increasing our level of precision. Does that make sense? And we always talk about you can't make, when you multiply things together, you can't make your answer be more precise than your least precise number. So in other words, if we measured everybody in this room's height 2 inches, right? Here's a 5'6", here's a 6'2", here's a 5'10". If we add them together and divide by the amount, are you comfortable we're going to get a big decimal? Let's say the average in this class is 5'10.3456" inches. You cool? Right, because we're just dividing, right? We're going to get a big long number in our calculator. Can I say that this is the actual precision of the measurements that we took? No, I can only say 5'10". Why? Right, I didn't actually measure this level of precision, right? We didn't go into the decimal places of inches. Does that make sense? Cool. I want to make sure you're with me. So that's precision. So what about accuracy? What's accuracy then? If you flip over to page 16. With the real value. Okay? So precision is exactness. And accuracy is with the real value. Okay? So let's say we're measuring height. And Isabella comes along and she measures my height. And she says, boy, Mr. Hess, you've grown. You're like 7'6". It's impressive. No, you're not even 7'6". You're 7'5.75". Ooh, wow. Mr. Hess, I'm impressed. You had a growth spurt over the summer. Is she very precise? Man, she went down to the 100th of an inch. Is she very accurate? No. As much as I might want to be 7'6" at some point in my life, I am not, right? So exactness versus realness. Judging it to the standard, right? And so that's why I like these the bullseyes, right? So, if I shoot a bunch of arrows and they're right here, boom, 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 make them bigger so you can actually see them. What would you say about my level of precision? I'm pretty precise, right? I mean, those arrows are all grouped in a very small area, right? What would you say about my accuracy? Well, I'm hitting the target. It's harder than you think, right? Okay, what if instead my shots looked like this? How's my precision? Yeah, not that great. Again, I'm hitting the target. How many of you ever shot a gun before? I'm just curious. Yeah, it's harder than you think. Paintball counts, sure, yeah, I'm cool with that. Yeah. So this person, their precision is not that great. How about their accuracy? Still leave a little to desire, right? Because again, we're assuming you're trying to put them right here, right? This would be if we took Nick's shooting. This would look something like this, right? Boom, 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 right in the center. That's not mine. I can't do that. So what would you say about the person in red? How is their accuracy and precision? They die. Are they accurate? They have hit the exactness. They've hit the real target that they're trying to get to, right? Are they precise? All of their shots are grouped in a very small area. Absolutely. Does that make sense? And again, you all heard this before. We've talked this one before. Okay, last piece for today. I want to mention about some techniques of good measurement. So they show you a real nice example of this on page 16. A parallax. You all heard this word before? 2 L's, right? Parallax. So they're showing you a spring scale, which we're going to use. It's one of the ways we measure force. And can you see that if you look directly perpendicular to that measurer, you get one reading. But if I look from above, I get a second reading. You see that that's on page 16. Are you with me? The same thing if I'm trying to measure how much I have in a graduated cylinder, right? I don't put it on the table and look at it like this, do I? No, what do I need to do? I get down and I get flat, right? And what you're trying to do is to get rid of your parallax. So one of the things we want to make sure we do is that we're taking good measurements, right? Think about if we're doing time measurements, how we can make sure that's precise. If we're taking length measurements, making sure these are precise and accurate. Are you with me? Because more than likely, if you're getting troubles in your labs, it means you're not being very precise or accurate with your measurements because of some of these poor techniques. Any questions there? You guys are easy today. All right, I'm looking for you to please complete 15 to 20, right on the bottom of page 17. You may have to use some of the pieces from back in section 2 about SI units and the SI prefixes. That's all in your textbook. But 15 through 20, please. And again, have this before the start of class tomorrow. We've got about 3 minutes you can work currently. And then we'll jump into the lab tomorrow. Okay?